Hi, my name is Emmanuel Yurquera, and I am a scientist at the Translational Research Institute for Space Health. Now I want to tell you some of the scientific facts of things that happen to humans as they go to space. Here on Earth, we are in a one gravity field, so really our weight is all going downwards. And when astronauts go to space, there's no gravity. So what happens to the spine is that astronauts actually get a couple of inches larger than when they are here on Earth. A lot of the spacesuits, they need to be designed taking these things into consideration. That way, when astronauts are in space, these suits need to be tailored, taking into account the fact that they will be a little bit larger than when they are in space. Of course, when they come back to Earth, it takes some time for them to get back to their normal height. So this is just a transient thing that happens as they're exposed to these microgravity or zero gravity environments. Another interesting thing that happens, also related to the lack of gravity in space, is the fluid shifting. So astronauts, when they go to space, really the blood that normally here on Earth is mainly in our legs. When they go to space and they encounter microgravity, this blood actually moves to the head. Some scientists and some people in the field, they call it the chicken leg polyphase syndrome, because really what happens is that the legs get a little bit thinner and then the head gets really flushed. It looks really swollen. This also has the effect that the sinuses, some of them feel really clogged and really flushed. So in space, astronauts say that some favorite foods is spicy. That way they get to clear the sinuses. Because of the lack of gravity, they start losing bone and muscle. As the space program has been evolving and we have been funding more science in these areas, now NASA has very strong capabilities to provide exercise devices. One of them is called the A-Ready, Advanced Resistive Exercise Device, that is a series of weightlifting. And you would think, like, how do you do weightlifting in space where nothing really weighs in space? NASA engineers developed these devices by having a huge piston that can actually have vacuum, the vacuum of space. So this piston, you can change how much vacuum it has, and it can simulate the weight that you would normally have to lift on Earth. As they are pulling weights or running in the treadmill, what does it do vibration-wise or motion and vector-wise to the space station around the orbits? So all these devices is completely isolated from the space station. So there's a lot of mechanisms that keep them separated from the station. So regardless of the motion that they're doing, it will not translate into the space station that will potentially move it away from the vector. So all these devices are mechanically isolated from the structure of the space station. Currently on the space station, one of the biggest issues that astronauts have are sleeping. They usually cannot sleep as good as we traditionally would sleep on Earth. There's a lot of reasons for these. One of the most important ones is that there's a lot of activities on the space station. Constantly there's vehicles coming to the station and docking, so astronauts cannot sleep. The circadian rhythm, that means that 24-hour circadian rhythm gets disrupted. Also the lack of a 24-hour day. Now when you're in space and when you are going to be in the mission to Mars, there's going to be no windows. So there's going to be no blue light, there's going to be no dawn, no dusk. So astronauts will very likely have issues with sleeping. So TRISH is funding some technologies that will allow the astronauts to sleep better. So we're looking at non-pharmacological ways to ensure that astronauts could be able to sleep better. And if astronauts sleep better, they will be able to perform better on the missions and ensure that the missions are safe.